about archiving ancient Roman rural settlements in practice, experiences, challenges, outlooks. And Dominik Hagmann is a classical archaeologist at the Department of Classical Archaeology at the University of Vienna, with special interest in digital archaeological method and theory, landscape archaeology, Roman archaeology, experimental, and also foot archaeology. I'm very interested in the last one, foot archaeology. And he has already archived numerous research data of these interesting projects also in Phaidra. So.
Okay, yeah, thank you very much. And thank you for the possibility to present some thoughts on this topic of digital archiving of digital archaeological data. Just 1 second. Okay, so I hope everyone can see the presentation. As said, I want to focus on 3 aspects, in fact, on some experiences, on some challenges, and also on some outlooks, although I think these are more some wishes than some outlooks regarding our archiving activities, but let's see. If you may think about archaeology and may Google the term archaeology and may find some pictures about archaeology, you may also have some pictures like in this slide in your mind about archaeology, especially the third one, the first row. So some guys brushing with a brush some human remains out of the dirt. Of course, these are some important aspects of archaeology and also of course of anthropology. But the thing I want to talk about today is more about, as already introduced by Susanna, is digital archaeology. So in fact, comparable to digital humanities, for example, in fact, the digital branch within archaeology are not only thinking about storing the data and not only thinking about for example, publishing data itself, but also thinking effectively about methods of gathering data, of collecting data. Mainly, and this is now a thing in archaeology which is quite common in my eyes and quite developed to some sort of standard, is using 3D models for everything, using 3D models for recording the shapes of artifacts, for example, like in the first picture in the first row, also from Google. So just some random impressions, but they are true in fact and really give a nice impression of this topic, but also of recording, for example, some shipwrecks, like in the middle part of the first row, but also of recording some archaeological features, so structures like ditches, like pits, like walls, and so on, like in the top right picture in the first row. So these are in fact, I think, quite good examples of what kinds of data I'm now talking about mainly. So it turned out that 3D photogrammetry, for example, but also 3D laser scanning, but photogrammetry in particular, is now used as a method for, in fact, recording everything. Archaeology is often about material culture, about artifacts, about finds, about sherds, about brushes, and so on. So about metal finds and so on, walls, as I said. So this method regarding digital photogrammetry proved to be very cheap, very efficient, and with really quite good outputs to be used for recording in 3 dimensions these features I just described. This is the first thing. The other thing is another very important topic in my eyes is spatiality. So spatial things about archaeology as a whole, and in particular geographic data sets, so geoinformatical data sets with spatial connections, because I think everyone is clear that in fact every single find comes from a certain find spot somewhere on Earth. So space on the one hand, and in fact 3D models, so to say, on the other hand, at the moment are, in my eyes, actually the really hot topics in digital archaeology, and therefore also, of course, hot topics if we want to think about achieving these kinds of data sets. So as I just said, digital archaeology as the branch in archaeology handling all the digital stuff, also often called computational archaeology and so on. Yeah, just some insights. Also treats analysis, for example, data collection, as I said, visualization of the data, and of course distribution of the data, which is also meant as some sort of public, some sort of possibility to give the public, on the other hand, the possibility to interact with archaeological results from various archaeological projects. What I want to talk about today is data which were covered, data sets which were collected in course of our field archaeological campaigns in Italy mainly, but also in Austria, but also in Jordan. So most of the data I'm talking about now has been collected during excavation, like in this picture. So just to give some sort of small impression, when we started the collection of the data in 2012 at an excavation site in Tuscany, near Florence, in so-called Mulino San Vincenzo, a Roman villa rustica, so a Roman farmstead. We just gathered or we just collected, in fact, around 2 gigabytes of the data. But as you see in this graphics, with time going on, with implementing new methods, especially photogrammetry in 2015, you see a huge peak in the data and in the volume of the data and the amount of the data. And this data was steadily growing. It's not an exponential growth, of course, but it was steadily linear growth, in fact. And now we have just the raw data of just one excavation of around the half of a terabyte. But as said, this is just the raw data, so you have to multiply the whole amount to get an impression for the whole volume of the data, so around 2 terabyte just for one excavation. As I said, I know it's not that much, but on the other hand, it's not that less. So especially if you compare this evolution of the amount of the data between just 8 years, in fact, or 7 to 8 years. So I think this graphics illustrates quite a good way why, on the one hand, it's really needed in archaeology to think about the archiving, about the storage and so on the one hand. On the other hand, also to think about choosing the right methods, choosing the correct methods, thinking about the reasons why I'm using a certain method and so on. But this is another story. So as I said, mainly 3D models, but of course not exclusively 3D models. There are plenty of other data types which are collected during archaeological excavations. In particular, for example, various kinds of structured tables for the single finds, structured tables for the structures, so like walls and so on. A huge amount, a vast amount of different kinds of raster images using drones, using conventional digital single reflex cameras, for example, using action cams for time-lapse videos, which are based on a series of single shots, of single pictures, of single images, but also vector graphics, for example, describing the single archaeological layers, or this single contexts, which are in fact the very the central thing everything is going on about. So these single layers, these single ecological units of stratification are usually described using raster images, are usually described using vector graphics. I don't want to talk about the technical framework. If somebody is interested, of course, we can do this afterwards in the discussion. But the important thing is that we have different kinds of different data sets. Vector graphics, for example, used in a geographic information system, but also vector graphics, for example, used in a program for drawing like Inkscape or like Adobe Illustrator. So also within a certain class of data type, there are also completely different kinds of files and so on. So we have a huge diversity of different data types, but also, of course, of different file types. Then, of course, for example, thinking about the 3D models, point clouds, meshes, so three-dimensional surface models of single finds, of single structures, as I said, but also of whole sites. So really huge, also regarding their own volume of the single file, huge files of some gigabytes just for one raster image, or just for one mesh, for example, if we are thinking about geoinformatical data. So also videos recording the single actions on the excavations, so videos used for paradata, are also some kind of data set. So we are, as said, different kinds of data sets with different needs, for example, for storing them. Just here as to make the things more visually supported with some further information. Here we have a garbage pit, so a pit which has been used in ancient times to put their rubbish there. And this pit is the single models within this video are in fact the single layers which were which contain the rubbish and which serve the backfill of this pit. And every single working step, in fact, is one of these layers, and we recorded every single step. So every stratigraphical unit has been recorded, has separately excavated, and for every single layer, so we have a single 3D model. So for example, just for one rubbish pit, there are, let's say, 20 different 3D models and plenty of other information available. Just as an illustration, a sketch of the data model of our find database, which is also some very important kind of information regarding these archaeological features, but completely different from the surface models used for this 3D model. And then we have just structured table data on the other hand, for example, used for describing the artifacts. So we have, as said, a real huge diversity of different kinds of archaeological information and archaeological data. So, okay. Along with the data, there are, of course, these different more aspects, like, for example, electronic publishing of the data itself, interactive displaying of pictures, of interactive maps, and so on, online mainly. Yeah, okay, electronic publishing is mentioned twice, I see. Although paper is still used, paper publication are still huge books, for example, are still a thing in archaeology, but nevertheless, I think articles, scientific articles, but also the publication of the research data themselves are a steadily growing new, very important aspect. And if you think in a realistic way about the whole question, it's not really possible to publish a 3D model just inside a book which is printed somewhere. So you have to think about a way also to publish the model itself, the data itself, so that it can be reused too. If the model is just published as some sort of image, as some sort of rendering in 2 dimensions in a published paper book, nobody can really work with the model itself. And then, of course, things like streaming of all the videos, streaming of the 3D models, and so on, so on. So we have to think about ways of communicating, of disseminating the data in a digital way to the people, to the interested researchers, to an interested public, for example, which is also a very important thing in archaeology, and a lot of people with absolutely no ecological background have a real high interest in archaeology usually, especially people from the local area. So if you're excavating, for example, in Upper Austria, usually the people from Upper Austria, from the municipality, from the next city are usually really interested. Of course, not all of them, but quite a lot. So we have to think about ways which are in fact which are useful for both. On the one hand, for the researchers, but which are also useful for example, interested people with absolutely no ecological background to work with our data, mainly via the internet, so that it is possible for them to work online with the data. Yeah, so much said about this, but exactly this is the point in my eyes where Phaidra comes to play, because first of all, as every one of you is aware of that point, Phaidra is capable of permanent archiving of all kinds of data, and this is a very important thing, especially in archaeology, that, for example, not only structured text is possible to be archived at Phaidra, and that it's not only that Phaidra, for example, is not only capable of just only archiving some so-called shape files. So this is some sort of geoinformatical data type for vector or for point data for polygons. So because that doesn't matter at Phaidra. Phaidra just, it's possible to store everything at Phaidra, and that's is really cool in special, especially for archaeology. It's also really good that every object gets a permanent digital signature, especially that it's possible at the University of Vienna to use or to receive a DOI for special data sets, for example, for the whole collection, or for archived books or archived maps. Maps, for example, are also so newly produced maps as geographic visualizations of or cartographic visualizations of the archaeological work are a really important thing in archaeology. So, for example, for making high definition maps available for everyone who is interested in the topic, that's also a great way for providing them on Phaidra via the internet, and also supplying these data sets with DOIs, for example. And what's also very interesting, and it has been already said today, is that it's possible to describe the things, the objects in Phaidra in multiple languages, for example, in Italian and in German and in Arabic and in English at the same time. And this is also a very good thing for us, since our projects regarding ancient Roman rural settlements at the moment, for example, focus on Italy, on Austria, but also on Jordan. So not at the moment on Jordan cause of COVID, but usually maybe when we can continue also our research in Jordan. And that's really a really good thing that it's possible also, for example, to at least describe our data, not only in German, but also in English, for example, since these are international projects. And then, of course, the metadata. Don't want to go too deep in that, but what's also really interesting and also really a really good thing at Phaidra is the possibility regarding the rights and regarding the licenses and the licensing of the different data sets, and that there's also the possibility to choose between different kinds of licenses, because for example, if you want to publish some source code or something like that, you need another open license than if you want to publish a photo of a certain feature. Another thing which is very important for us and which is really a good way of distributing all the data sets, as I said before, is that there's the possibility of a seamless website integration of the different Phaidra collections. So in one's personal project web space, for example. So we have our project website, Roman Rural Landscapes, which is in fact an initiative and some sort of umbrella website for different projects on rural landscapes. And there we also have launched some sort of data portal where it's possible to get everything which is stored on Phaidra just using the same website. You do not have to leave the one website and then search on Phaidra. Everything is possible through this seamless website integration to be done on one single web page, in fact. Another way of publishing our data is our so-called web mapping applications, so interactive maps. Here some sort of lightweight, I called it lightweight web mapping application, completely done with open source software, just to show the single layers, the single stratigraphic units of the 3D model of the video of the. These are the same models like in the 3D model video I showed you before. So and there's possible just to click on every single layer, and then you get a link, and the link sends you to a download page, in fact, which is de facto the data set which is stored on Phaidra. So it's just using hyperlinks, a very basic thing of websites of the World Wide Web. Just using hyperlinks just gives you the opportunity to connect the long-term storage space with, for example, this web mapping application, which can serve for interested people, for interested researchers, for interested other guys, as a graphical user interface, as I said, interactive map for example, studying these single layers of this garbage pit in Mulino San Vincenzo, in this Italian Tuscan Villa Rustica, Tuscan farmstead. So just some insights how we are using Phaidra at the moment. Challenges, I also said I shortly will talk about challenges. I think the main challenge is time. It's not. I know it. This is not that the great idea and the super sophisticated thought, but I think time is the main problem in working regarding digital data in general, and time is the main problem regarding working with digital data in particular when you want to archive it, I think. So most of the work of our project group is regarding digital things is done by me, so I can say I'm some sort of one-man show, and this is often I see I have data from, let's say, 2017, and every year I say, so next year everything will be archived on Phaidra, for example, and then after 1 year I say, yeah, next year I will archive everything on Phaidra, and so on and so on. So I really hope that I will be able in 2021 to finish, for example, the archiving works for all these data sets of this Italian villa I was talking about. But in 2018, I already told the same story, that I will hope that in 2019 I will be able to publish everything on Phaidra, so and so on. So I think really time is really very important thing, and this is also important, I think, for projects in general, since, for example, for the Austrian Science Fund, FWF, it's anyway mandatory to provide some sort of data management plan. I think this is not just a saying. So I think it's a really serious question to think seriously about how should the data after the project be archived. What are the ways we want to provide to get some access to the data and so on. So I think these are really the challenges regarding working with digital archaeological data and working with digital repositories. I think this is in fact the main challenge, and this point of archiving, of course, within a complex network of other tasks, from collecting to publishing to post-processing and so on. Yeah, another challenge and also another outlook, or as I said, a desired functions that would be great in Phaidra. We already talked about that last year, for example, in course of a workshop. So at the moment, for example, we have, so our project group tends to visualize or tends to use another platform. It's called Sketchfab. It's some sort of YouTube for 3D models, to provide access to this 3D models. Since, for example, and at the moment, at least, an on-the-fly visualization of 3D objects, but also of spatial data, for example, is not really possible in Phaidra. So you can't go to Phaidra and just look at the model and then decide, okay, do I want to download it or not? You have to download it and then open it in another program, and then you can prove it if it's, for example, the right model for you or not. So that's why we are at the moment using another platform for visualization, while, for example, the Archaeological Data Service, which is a huge British repository for archaeological data, already provides some sort of open source 3D viewer for exactly the same task I was talking about. So for archaeological layers, for so-called archaeological stratigraphies, and I think this would be, at least in my eyes, a very important thing to be added to Phaidra, at least in the next years, to have the opportunity, just as it's possible at the moment with videos, as it's possible with pictures, that's also possible with 3D models, since I think that 3D models will become much more common also in other disciplines than they now are. For example, think about the new iPhone. There are certain versions of this iPhone where a LiDAR scanner, so a laser scanner, is already built in. So you have, just with a smartphone, the possibility to make not only photos or videos, but also 3D models. And I think this is a trend which surely will go on and on and on. Anyway, yeah, as I said, Phaidra, we are using it, and it is a secure and sustainable platform for long-term archiving of archaeological data, especially regarding the fact that Phaidra accepts every kind of data. Then that there are already various possibilities of integrating Phaidra in our digital archaeological practice, for example, just through linking from one thing to Phaidra, because there are stable links. So it's absolutely no problem to establish a stable connection between two different user interfaces, in fact, on the web. And then, but on the other hand, would be great, just as an idea, that some modifications, in fact, are maybe implemented to Phaidra in the next years. For example, as I said, to be able to visualize 3D models on the fly, just on the platform, and not so that we do not have to use other solutions, for example, as it is at the moment. So thank you very much for your attention, and yeah, I hope it wasn't too fussy for all of you.
Thank you very much, Dominik. Thank you for the nice presentation and for the insight in your research. And I think it was very interesting. And thank you, of course, also for the praise of Phaidra.
Yeah, it's true. So it's just a true story. Yeah.
Thank you. So, do you have any questions to Dominik? Yeah, it's Friday afternoon, so
yeah. So I just will paste the link to our webpage into the chat. So if somebody is interested, please have a look. Most of the web pages at the websites are in German, but there are some in English at least. And at least regarding our long-term archived stuff, everything is, we try to make everything at least bilingual, so English and German mostly.
So I think it's very interesting for us to see that the researcher use Phaidra in a different way, in a complete different way. But it's nice to see and also to hear from you and from others what they need, what are their requirements. So it's good for us to think about what can we do, what is possible, what is not possible, because we have also a problem with time, of course.
Yeah, everyone has it.
Luca is here. Do you want to ask?
No, I just wanted to say thank you, Dominik, for your Dominik, is that right? Yeah.
Yeah, Dominik.
For your presentation. And in past times, we also had the necessity, the need for archiving 3D objects in Phaidra, and surely in the future we'll have more. So I agree with you that having a visualizer in Phaidra that is able also to show, to interact with a 3D model would be useful.
Yeah, I think thank you very much. Because, yeah, as I said, I think this, as you said, there will be for sure more and more 3D models in the next 10 years, I think.